Okay, hello and welcome to another video on our homework, this time simultaneous equations and inequalities. So let's get going. Okay, in question one, my guess is if you made a mistake here, it will be a slip up rather than anything serious. I'm just going to double. There's two ways you can solve linear simultaneous equations. You can use elimination or substitution. I'm going to use elimination here because it's set up for that. I'm just going to double all of A. I like to actually write down 2a here as well. And then I'm just going to add them together because that will give me 5x. The 2y and minus 2y cancel. Then you get 5 here. And so x is 1. Now, don't forget to find y after you find x. It's easily done. Looks like y is going to be 2 there. And it should work in the other one, remember. These are dead easy to check. You've got 3 plus 4, 7. Okay, let's try it on the next one. Same thing again, really. I think I'm going to there's not really much in it. If I treble, I'll treble the B if you like. If that's A and that's B, I'll treble B. So I've got minus 3u plus 18v is 120 plus 18, 138. And then that's 3u. I'll just write the other one down above it. Is minus 26. So what have I got here? That's 3b. Add them together again. 16v is going to be, that's supposed to be 138. Add them together, you're going to get 38 minus 26, but that's 112. And I think that gives you v as 7, because 7 times 16 is 112, I think. And therefore u is going to be, what we got here? That would be, let's plug it in here. 6 times 7 is 42. We need to get to 46, but this is negative, so I guess that's minus 4. Now let's just check it in the other one. 21 plus, this doesn't look right by the look of it. I think I've done something wrong. See, that's what I like about these questions. You can normally check it. Let's have a look. You know, we're going to get, oh no, I'm just plugging them in the wrong way around. Minus 12, minus 14, minus 26. Yep, they work in both equations. It must be true. Okay, last one. We're going to have, I think I'll double the second one this time. So I'll just write down the first one again, unchanged. But the second one I'm doubling, so I'm going to write 2b because that's A and that's B. I do like labeling these. Minus 2p plus 6q is minus 10. Add them together. And there have all been ones where we add them together because the signs are different. You get 2q is 4, so q is 2. And p is, let's have a workout. If q is 2, that would be minus 8. Add it on over there, get 22. I think that makes p 11. Minus 11 plus 6 is indeed minus 5. Checked. Cool. So not too bad, I hope. Okay. Non-linear simultaneous equations is what we've got next. So one or more of these equations will be not linear, which means it's got squares or it's something like this, xy equals 8. Those are all non-linear equations. These take a little bit more effort, to be honest with you. You have to use the principle of substitution. Now, it doesn't matter whether you make x equal 9 minus y or y equal 9 minus x. I'm going to make y equal 9 minus x. I'm going to then have x squared minus 3x times by 9 minus x plus 2 times 9 minus x all squared. Yeah? And that equals 0, remember. And so I get x squared minus 27x plus 3x squared plus 2 times 81 minus 18x plus x squared, all in brackets, equals 0. Simplifying this, we're going to have x squared plus 3x squared, but that's 4x squared, plus a 6x, plus a 2x squared is 6x squared. Yeah, I'm trying to do this like, I don't like skipping steps if it confuses people, but we're just collecting like terms here. Now, minus 27x, minus 36x, what's that going to be? I think that's going to be minus 63x. I'm going to write that down and just check it in my head. Minus 27 minus 36. Yeah, minus 63x. And then lastly, we're going to have a plus 162 here on the end. Looking at that, I think it's all divisible by 3. I was going to say 6 there, but 63 is a sticking point. So let's divide it by 3. You're going to get 2x squared minus 21x. Plus, we're dividing this by 3, aren't we? So I might even do this with just there, 162, 54. 0. And now we've got to, factorize or, indeed use the quad formula. But I suspect this one factorizes. Let's have a little look. I'm a guesser on these factorizing ones, but if you don't want to do it by guessing, do 2 times 54, which is 108, and then find two numbers that add to give minus 21, but times to give 108. Now you can do that if you do a prime factor decomposition on 108. You get 3, 3, 3. And then you can kind of think, okay, how am I going to get a difference of 21? Because they need to add to give minus 21, which kind of means like they're both kind of negative, if you see what I mean, and they both times to give 108. Well, how about if we had like 27 and 4? No, that's not quite right. What about if we did instead, let me think, 9 and 4 times by, no, that's not going to do the job. 3 times 3 is 9. 18 and 6. No, I'm not sure that this actually factorizes, I'm just going to quickly check on my calculator. I'll probably realize it does factorize and then have egg on my face. Obviously, you can always do this in any kind of question. Just check on your calculator whether it factorizes. It does factorize 6 and 9 over 2. So what did I miss there? Should be like that. So I'm guessing that one would have been doubled. And 9 and 12 is 108. Yeah, I missed that one. Okay, let's just check it though. Minus 9x minus 12x is indeed minus 21x. So you get x is 9 over 2, or x is 6. And then you get your corresponding y coordinates. And as x plus y is 9, you're going to get y is 9 over 2 here, or y is 3. It is helpful as well sometimes to write it down in coordinate pairs. 9 over 2, 9 over 2, and then 6 and 3. Okay, I'm just going to pause the recording because we've got registration now, but I'll be back in 1 second. Oh, yeah, sorry about, well, you wouldn't have had a break there at all, but I just quickly paused the video. Okay, so part B, xy equals 8 and 3x minus y is 10. Okay, the trick here is to do something like this. Y equals 8 over x, or x equals 8 over y. Doesn't really matter. But then we've got 3 times x minus 8 over x equals 10. And then we times through by x, so we end up with a quadratic. 3x squared minus 8 equals 10x. We like our quadratics to equal 0. So that gives me 3x squared minus 10x minus 8 equals 0. I'm a guesser on these parts. You can, of course, sneakily use your calculator and reverse engineer the roots. But if you want to know how to do it properly, it's like this. 3 times minus 8 is minus 24. Now find two numbers that add to give minus 10 and times to give minus 24. They are, of course, minus 12 and positive 2. And then this is a really sneaky way of doing it. Just write 3x minus 12 and 3x, whatever that number is, basically plus 2, but cancel down. So that can be divided by 3. So that's actually x minus 4. So I'm just going to scribble that out and make that x minus 4. And then you've done it. Well, you factorized it, but you haven't quite solved it. So let's quickly solve it at the end. We need our x values and our y values. X is going to be 4, in which case y would be 2. It's helpful to write it down as a coordinate pair, like I say, so 4, 2. Or x is going to be minus 2/3, and that's what makes that bracket 0, in which case y would be, let's think about this, minus 3 over 2 times a, minus 24, minus 12. Yeah, 2/3 of 12 is 8. Yeah, perfect. So we get minus 2/3 minus 12. Done. Okay, part C. Let's have a go at part C now then. Y equals 4x. We're plugging that in here. That's what I'm going to do. So I'm going to plug in very carefully 4x all squared minus 2 times x times 4x. And that should equal 160. So that's going to give me, after I square it and times it by 3, 48x squared. Remember, you've got to square the 4 as well as the x in that situation. Most students miss that. Minus 8x squared is 160. So 40x squared is 160. So if I look at it, x squared is 4. So x is 2 or minus 2. In which case y would be 4 times that, which is 8 or minus 8. So you've got 2/8 minus 2, minus 8. Yeah, and that should be good. Okay, right. What have we got next? In each of the following questions, find where the two graphs cross and show the crossing points on a sketch. Okay, weird that it starts on C. So they cross when this y coordinate is the same as that y coordinate. And that's why I'm allowed to do this. 3x minus 2 is x squared minus 3x minus 9. And so that gives me 0 is x squared minus 6x plus minus 7. Factorize it, x minus 7, x plus 1. Looks good to me. So x equals 7, or x equals minus 1. What you find the y's. 21 minus 2 is 19, and minus 3 minus 2 is minus 5. Okay, I'll do the sketch down here. We've basically got a quadratic and a straight line. The straight line is steep and goes through minus 2. The quadratic, I mean, I suppose we could quickly complete the square to find out where the lowest point is. That would be minus 2 1/4 minus 9, which is minus 11 1/4. Just casually completing the square in my head. And so you know it's at 1.5 and minus 11.25. And also it goes through minus 9. So it's going to be something like this. And it will intersect there at 719. But also back here at minus 1, minus 5. Yeah. And I know my diagram's not brilliant or to scale here, but that's the general idea. You could put the minus 9 where the quadratic hits down there as well. Okay, what about this one, part B? Let's have a look at that. What have we got here? Well, probably easiest to make this y equals 3 minus 2x, and then say 3 minus 2x is 6 plus 4x minus x squared. And then what do we have? We have x squared. We're going to take away the 4x, we're going to get minus 6x there. We're going to take away from the 6 from the 3, we're going to get minus 3 there, equals 0. Now, let me just check I've done that right, because that doesn't look like it factorizes to me, which is slightly surprising. But I suppose it could have inexact roots where it crosses. Let's have a quick look. Let me just check. Looks right to me. 3 minus 2x and 6 plus 4x minus x squared minus 2x. Yeah, that's fine. So we're going to have to complete the square here to solve this, or use the quad formula. That's going to give you minus 9 minus 3, which is minus 12. And so you're going to get x equals, well, if I can, I'll do it slightly slower. You're going to get x minus 3 squared is 12. And so x is going to be 3 plus or minus root 12, in which case y is going to be slightly more awkward once again. You're going to have to plug this in and double the x. So that's going to give you 6 plus or minus, and that is 2 root 3. So if we doubled that, yeah, I'm going to have to do this slightly slower. It's a little bit annoying. You'd probably be using your calculator at this point. Y equals 3 minus 2 times this, which is 6 minus 4 root 3, or y equals 3 minus 6 plus 4 root 3. And so we get y equals minus 3 minus 4 root 3, or y equals minus 3 plus 4 root 3. And that's for when x is 3 plus 2 root 3, and x is 3 minus 2 root 3. And there we go. So that was a little bit more awkward. Now, in terms of the sketch, we've got an upside down quadratic here, and it goes through 6 on the y-axis. So it's going to look something like this. And then we've got 3 minus 2x, which is a straight line going through 3, going down, something like that. And then the intercepts are, well, that could be like 3 minus 2 root 3, which is just about negative. In fact, let me label it in a slightly more casual way. Let's call that one A and this one B. Well, then B is over here, because that's where you're going to get the negative x coordinate. and A is over here, that's where you're going to get the positive x coordinate and the negative y coordinate. And as you can see, that's the case there and there. Hope that diagram's clear enough. That's the kind of thing you've got. Okay, cool. Let's go on to the next one. That was a kind of fiddly one, that one. Number 4. Wow, this is busy homework, isn't it? There's a lot to do here. Okay, the line 2x minus 3 touches the curve y equals x squared plus kx plus 6. Find the possible values of k. Well, let's talk about this. Firstly, when curves touch, there is a repeated root. A repeated factor and a repeated root. Hopefully you know what a repeated root is. It is where you get something squared. Another way of looking at it as well, of course, in fact, they probably want you to do it like this, if they say find the possible values of k, the discriminant should equal 0 for your resulting quadratic, because it should just have one solution. Essentially, it works like this. When you've got a line and a curve, like a quadratic and a straight line, you could have two solutions. In other words, the line crosses the curve twice. You could have one solution. In other words, the line just touches the curve. Or you could have no solutions. And they correspond to the three things which can happen with the discriminant. B squared minus 4ac is bigger than 0 here. B squared minus 4ac equals 0 there. And b squared minus 4ac is less than 0 in that case. So that's what we're going to be using for this one. So we've got y equals 2x minus 3 and x squared plus kx plus 6. Let's do that. Y equals 2x minus 3 and y equals x squared plus kx plus 6. Okay, so 2x minus 3 equals x squared plus kx plus 6. So 0 equals x squared plus, now let's call this x times k minus 2, because that's going to give me kx minus 2x. And when I move this onto this side, I'm going to have a minus 2x. Then we're going to have plus 9 on the end. Now, we want this discriminant to be equal to 0 to make sure there's one solution and it touches. So I'm going to do b squared minus 4 times 1 times 9, and that should be equal to 0. In other words, k minus 2 squared is going to be equal to 36. In other words, k minus 2 is equal to 6 or minus 6, because when you square root, you get two values, and k equals 8 or minus 4. Done. The hint that you need more than one value there is at possible values of k. It's giving you a little hint there, it really is. Okay, let's move this down because it's kind of getting in the way of all the work we've already done. Done a lot of work here. Well done, people. Let's move it down a bit. There we go. Cool. Okay, solve these inequalities. These are all linear, which means they're much easier than the quadratic ones. Inequalities are hard. They're genuinely difficult. When they're linear, though, they're not bad at all. You just treat it as if it was an equal sign, even with these bounded inequalities. Let's add 9 to this thing, and this thing to get rid of the minus 9 first. So we get 10 is less than 4x, which is less than 14, yeah? And then I'm simply going to divide by everything by 4. So I know the values that x is trapped between, because this is a bounded inequality. And we want to know the values that x is trapped between. So now simply divide everything by 4. So you're going to get 2.5 there. You're going to get 14 divided by 4, which is 7 divided by 2, so 3.5 here. So x is trapped between 2.5 and 3.5. Sorry for rubbing out my intermediate step there, but I just wanted to get it written down like that. This one, probably easiest to divide by 3 first. So x minus 5 is less than or equal to 8. Then add on the 5, so x is less than or equal to 13. It's important to note as well that these genuinely work. What we're saying here is provided you give an x value bigger than 13, sorry, less than or equal to 13, this will be true. So when you make it 13, 13 minus 5 is 8, 8 times 3 is 24. So this is just about true because it's allowed to be equal to 24. But if I picked a value of x less than 13, so like 2, this would also hold. 2 minus 5 is minus 3, times by 3 is minus 9. Yes, minus 9 is less than 24, so it holds. You see what I mean? We genuinely are solving it. On C, I'm just going to add 2 and then divide by 3. So I get 3 1/3. I'm just going to write it as 10 over 3 and 13 over 3. That would do. Done. We can always leave them as top-heavy fractions when we're in A level. It's absolutely fine. Okay, take away 7. You're going to get minus 42. Minus 6. Divide by 6. You're going to get minus 7 and minus 1. X is trapped between minus 7 and minus 1. Ah, this is a bit more of an interesting one. We're going to have to collect all the x's together. Let's try taking away, let's take away 2x from everything. This is slightly more awkward. Let me write this down over here. I'm quite pleased to see one which is going to make me think. So we've got an x plus 3, a 3x minus 5, and a 2x plus 1. Sometimes it's helpful to write these out separately. So consider this one. Well, actually, let's just start by putting all the numbers. You know, let's try and hammer down what we've got with the numbers here. Actually, no, I am going to start writing it out separately. So we want x plus 3 to be less than or equal to 3x minus 5. And we want 3x minus 5 to be less than 2x plus 1. Yeah. Now, this could lead to some form of contradiction. We might have to decide carefully at the end where, you know, what values of x are the case when both these inequalities hold. So first I'm going to take away the x. And then I'm going to add the 5. Oh, and then I'm going to divide by 2. So I get x is greater or equal to 4 there. And I think that's fine. Same on this. I'm just going to take away the x, 2x, sorry, this time. Add the 5, and I get x is less than 6. So x is both greater than or equal to 4, but it's also got to be less than 6. So I reckon that x is trapped between 4 and 6, but it's allowed to be equal to 4. Now, when you get things like this, because this was quite a hard one, let's check it. Let's see if this all holds when x is 5. You get 8 there. You're going to get 15 minus 5, which is 10 here. And then you're going to get 2 times 5, which is 10 plus 1, 11 here. See, it genuinely works. It genuinely works. So provided x is trapped between those values, you're going to be good. But that was quite a tricky one. I quite like that. It made me think. Okay, number 6. Now, these are quadratic inequalities. I suggest always drawing a sketch for these. I really do suggest always drawing a sketch. Now, step 1, though, is always try and factorize it if you can. And I think minus 6 and minus 10 and plus 4 should work well here. Good. And now try and sketch it. Now, this is the way I explain these. Not the best way I expect, but this is just my effort. Okay, we know that the graph looks like that. And this is the graph of y equals x minus 10, x plus 4. Now, why is this that this is greater than 0? In other words, we want y to be greater than or equal to 0. Now, where on this curve is y greater than or equal to 0? Well, it's there and there. That's where y is greater than or equal to 0. Now, when you solve this, you're trying to find the values of x for which this is true. So what values of x are on this curve where y is greater than or equal to 0? Well, we could see x could be less than or equal to minus 4, or x is greater or equal to 10. Now, there's no way of writing that in one single bounded inequality because it's describing a region which is less than or equal to minus 4, or it can be greater than or equal to 10. You can't write that down in a single one-liner. And that's the answer there. I call these questions beards and sideburns questions. This is a sideburns because quite clearly you've got sideburns there. Whereas if you're going underneath, it would be a beard. And yeah, that's the way it works. Okay, let's try the next one. Y squared minus 4y minus 5 is less than 0. I hope you don't mind immediately me rearranging it into that. Y squared minus 4y minus 5 is less than 0. Let me just check that's correct. Yep, I've taken away the 4, I've taken away the 5, and it's less than 0. Factorize it. And so what have we got here? Now, your y is your x really here. It's going to go through minus 1 and 5. Now we want under 0. In other words, these values need to be less than 0. In other words, y is trapped between minus 1 and 5. Little sketch, color it in, and you're good. Let's try the next one. 5x squared is less than or equal to 80. Well, x squared then is less than or equal to 16. And so you've got x squared minus 16 is less than or equal to 0. Now, if we use the same approach as before, which isn't necessary here because you can actually do it kind of like by common sense. I'll talk about that way of doing it in a second. But if you factorize that, you get x plus 4, x minus 4. And that's your y. So your quadratic is going to go through 4 and minus 4. And we want this to be less than or equal to 0 because we want y to be less than or equal to 0 here. And so the answer is x is trapped between minus 4 and 4. This makes sense here because if x squared is less than or equal to 16, sure, you're going to get x is less than or equal to 4, but x also needs to be bigger than or equal to minus 4, just because of the way the negatives work. Because if you have minus 5 and you squared it, you get 25, and 25 isn't less than or equal to 16. That's why you have to be careful with quadratic inequalities. It's slightly more difficult. Okay, D and E got x squared plus 8x plus 10 is greater than 0. Let's do it over here. Oh. X squared plus 8x plus 10, was it? I can't remember what, 10x plus 8? 8x plus 10 is greater than 0. Now, they're bound to throw one in a second where it doesn't factorize. I'm certain of it. They're going to do that. And I think we've arrived at that here. 2 and 5. No, it's just not going to factorize, yeah? So we want to sketch it still. But if it doesn't factorize, well, you could try completing the square, I guess, to understand more about this curve. So let's complete the square. X plus 4 squared minus 16 plus 10 is minus 6. So we know that at minus 4 minus 6, you're going to get its lowest point. But it goes through 10 as well. And if you wanted this to be equal to 0, you know, let's find where it hits the x-axis exactly. Then we're going to have this here. And so we get minus 4 plus or minus the square root of 6 is going to be x, yeah, because I'm going to add that, square root it, put a plus or minus before it, and then take away the 4, which makes sense because that's at minus 4, and so this is like minus 4 minus root 6, that's minus 4 plus root 6, yeah? Let's write that down for you. Get that beautiful symmetry which you get with the quadratics. And so, as we want this to be greater than 0, that's going to happen there and there, yeah? And so you're going to have x is less than minus 4 minus root 6, or x is greater than minus 4 plus root 6. And you've done it. So slightly more awkward, that one. What we got lastly, y squared plus 2y is greater than or equal to 0. Bit of a silly one, this one, because this one's just trying to catch you out. Y squared plus 2y is greater than or equal to 0. People forget how to factorize these. They really do. I was saying that to my GCSE class just yesterday, my year 10s. Okay, so what does this look like? Well, if we graphed it, it's going to go through minus 2 and 0. We want it to be greater than or equal to 0. And so you get y is greater than or equal to 0. Right, let's do the other one first. Y is less than or equal to minus 2. Or y is greater than or equal to 0. Done. Okay, right. Sorry, it's a bit of an epic homework, this one, isn't it? It's going on forever, it feels like. Taking me ages, one of my longest videos. Okay, so number 7. The length of a rectangular children's playground is 10 more than its width. The width of the playground is x. So I guess that means the length is x plus 10. Draw the picture. It's rectangular. Perimeter of the playground is greater than 64. Write down a linear inequality in x. So clearly we're going to have to do x plus 10 plus x plus 10 plus x plus x. And that is greater than 64. Let's simplify it because we'll have to do it later. 4x plus 20 is greater than 64. And you could even say 4x. Well, let's simplify it all the way. Take away the 20, you've got 44. Divide by 4, you're going to get x is greater than 11. Yeah, it's nice to tidy it up like that. B, the area of the playground is less than 299. Show that that is true. Okay, if the area is less than 299, then x times x plus 10 is less than 299. So x squared plus 10x minus 299 is less than 0. And I'm guessing that 13 times 23 is 299. Let me just quickly check that in my head. Yeah, I think it is. And they do indeed add to give positive 10. So they've actually got the factorized result there for me, which is handy. It probably would have taken me a while to factorize that. Cool, that's B. Okay, by solving the inequalities in A and B to determine the possible values of X. Good question, nice little modeling question. Okay, so it goes through minus 23 and 13. We want it to be less than 0. And so that implies that X is trapped between minus 23 and 13. But this is telling you X is bigger than 11. And so if you've got a number which is definitely between minus 23 and 13, oh, and also it's definitely bigger than 11, what you can deduce at the end is that it's between 11 and 13. Done. Number 8, solve these inequalities. Draw a sketch. It's useful. Yes, it certainly is. Let's factorize this. This is a cubic. Because they've all got an x term, I can do that. And then I can factorize it again. X minus 5, x plus 2. And so what has that told us? That told us it's a cubic which goes through minus 2, 0, and 5. It's a right way up cubic as well, which means it starts negative on the left-hand side and ends up positive on the right. It's not an upside down cubic as I might describe it. And then we want this to be bigger than 0. Well, this is the curve y. Yeah, remember we've just drawn y is x minus 5, x plus 2. So we want this to be bigger than 0, which happens here and here. So you can say minus 2 is less than x, which is less than 0, or x is bigger than 5. And you've done it. Sketches are really useful for solving inequalities, no doubt about that. Now this one, I'm going to take it actually over here, and then I'm going to sketch y equals 3 over x and y equals 4, yeah, on the same sketch. Now 3 over x is just like 1 over x, so it comes down like this and it goes like that on that side, and it does that on this side. Y equals 4 is just a flat line. Now we want the 3 over x to be under the 4. Well, the 3 over x is under the 4 when it's negative, and it's also under 4 after this intersection point. I can find the intersection point if I let 3 over x equal 4. Then I'm going to get x is, well, 4x is 3, and so x is 3/4. Oh. And so that's at 3/4. And so what can I say at the end? I can say either x is larger than 3/4 or x is less than 0. And that should give you all regions. You can check it as well, can't you? Like minus 1, minus 3, minus 4, it's definitely less than 0. That looks good. What about an x is 1? You've got 3 minus 4. Yeah, that's definitely less than 0. That's good. Whereas if you had a half, 3 divided by a half is 6. 6 minus 4 is 2. That is not less than 0. It looks like it's working. Okay, I'm guessing this is another one of these which doesn't factorize. So let's consider what the completed square form looks like on this. That would be x squared plus 4x. I need to take away a 4 and add 7, so that's just plus 3. So when you sketch this, it's always above the x-axis. It goes through 7 there, but its minimum point is at minus 2, 3. Now we're asking where this is less than or equal to 0. And I'm just going to simply answer this. This is not true for any value of x. The answer is there's no values of x which satisfy that. And you can almost do a proof by contradiction. You can see here, you cannot make this negative because x plus 2 squared is 0 or bigger, and then you're adding 3. Well, how could that ever be less than or equal to 0 then? It's just not possible. Okay, hope that was useful. I hope I didn't make any mistakes as well, because yeah, normally I've got the answer scheme to check, find my hilarious, silly regular. silly mistakes, but I haven't got it here. So hopefully I did it right. But yeah, thank you for watching. Keep up the hard work.